Right, I started with the first one, 1a, so I started with a simple one, then I moved on to the more complex ones. So the first one is f of x equal to x to the power of 6. If we use rule number 1, we will get f prime of x, we will get f prime of x is equal to, now here the constant is 1, so 6 times 1 will give us 6, x to the power of 6 minus 1. And the final answer, f prime of x will be equal to 6x to the power of 5. Okay, I've used rule number 1. Okay, I've used rule number 1. So the derivative of f of x equal to x to the power of 6 is going to be 6x to the power of 5. Okay, so that's the first one. Then B says find dy over dx. Now, dy over dx is the same as f prime of x. Okay, it's the same as gradient. So, from here we say dy over dx is equal to the exponent times the constant, that's 32x to the power of 4 minus 1. So the final answer, dy over dx will be equal to 32x cubed. Okay? So I've also used rule number 1. Okay? I've used rule number 1. All right. Any question? So I'm using the rules of differentiation to do these questions. Right. I have to be honest with you. This is the easiest part, but we are going to do more complex ones. Right. So let's move on to the next page. Right. This one here is the differential operator. That was 1c. This means the derivative of minus 7x to the power of 5. Now, when you are given the differential operator, the way you lay it out is different. The moment you decide to write down your derivative, you stop writing this part here. You have to stop writing that part. Let me use a different part. Right? You must stop writing d of x the moment you decide to find the derivative. So that's a monomial. So it will be the exponent times the constant, that will give me minus 35, x to the power of 5 minus 1, which means my final answer will be minus 35x to the power of 4. As you can see, I'm using my knowledge of exponents a lot. To find the derivative, you have to know your exponents. Okay? Let me move on to D. Now D, it's a quarter times x to the power of 8. Our constant there, it's a fraction, that's 1 over 4. So, first the derivative f prime of x will be equal to 8 times 1 over 4 times x to the power of 8 minus 1. And this will give me f prime of x equal to, now 8 divided by 4 will give me a 2, so I'll get 2x to the power of 7. Okay? Using rule number 1. I'm using rule number 1 here. Then the derivative of a constant, that is g of x equal to 15, is 0. You don't have to think that. The derivative of a constant is 0. Okay, let me just erase this, write it nicely. The derivative of a constant is a 0. So g prime of x is going to be 0. Right? Okay, any question? If you don't have a question, then allow me to move on to more complex ones. Slightly more complex. Right. All right, let's start with P. So with P, now P of x is the name of our function. So we say P of x equals to 5 over 4 x to the power of 4 plus 5 over 4. Okay? We are supposed to find p prime. P prime. Okay? Let me carry on. So from here now, since we have got a binomial, you have to find the derivative of the first term, then you add it to the derivative of the second term. So this will be p prime of x will be equal to the exponent times the constant. So that's 4 times 5 over 4 times x to the power of 4 minus 1 plus. Now this 5 over 4, it's a constant because it's not multiplying the variable. Therefore, the derivative of 5 over 4 is a 0. Okay, so I'll put the 0 there. The derivative was 5 over 4 is a constant. It's not multiplying x. If a number is not multiplying the variable, then we call it a constant. So the derivative of any constant is 0. Okay. So this will be equal to, now here, if you multiply 4 by 5, you get 20. Divided by 4, you get 5. Or you can cancel out this 4 and that 4. So you get 5x cubed. That's the derivative. The 0 obviously is just a placeholder. Okay? Are you following that? Yeah, this is the answer. Okay. Then for Q, you need to find dy over dx. Now, dy over dx is the same as f prime of x. But if the question says determine dy over dx, you must write your answer in terms of dy over dx. So here, our variable x is part of a denominator. So we need to use our laws of exponents. So we have to use this law, x to the power of minus n is equal to 1 over x to the n, by moving from right to what? To left. Also be aware that t is a constant, which means this t squared, its derivative is going to be a 0. Okay? If t is a constant, it means that t squared is also a constant. Alright? If t is a constant, it therefore means that its square is also a constant. So let me do that on the next page. I hope you are following that. So for Q, we have y equal to 4 over 5x to the power of 5, like that, right, plus t squared. This t here is a constant. That t squared is a constant. Because t is a constant, therefore t squared is also a constant. So before you find the derivative, you must make sure that the x is not part of a denominator. So that's where your laws of exponents come in. So we can write this as y. I'm not finding the derivative as yet. I need to simplify that expression. So this is the same as saying 4 over 5 times 1 over x to the power of 5 plus t squared. If I use the law which I wrote here on this page, that one there, you end up having 4 over 5 times x to the power of minus 5 plus t squared. Now it's simplified. The x is no longer part of a denominator, therefore I can now find the derivative. This is not the derivative. Okay? I'm just using my knowledge of exponents and algebraic expression. Right then, now I'm finding the derivative, dy over dx, that's equal to the exponent times the constant plus 0. Because the derivative of t squared, it's a 0 because t is a constant. Okay? Oh, sorry, I forgot to put my x there. So this will be times x to the power of minus 5 minus 1 plus 0. Okay? So this 5 and that 5 cancel, you'll be left with that minus. So our final answer, that is dy over dx, will be equal to minus 4x to the power of negative 6. Right? This part that you are doing is very important for your calculus. All right? Okay, let me do the last one before we go. Okay, the last one before we go. Right, let's find the derivative of that. Okay, this, it's not as scary as you think. Right, that's the differential operator. Right, so when I find the derivative of that trinomial, fortunately it's already simplified for us. So the first thing is just to find the derivative of each term. So the first term, it will be 6 times 1 over 3 x to the power of 6 minus 1, then 8 minus 8 times 3 over 4 times x to the power of 8 minus 1. Then minus 2 times a half, so that will be minus 2. Well, allow me to put that plus. Then I'll put minus 2 times a half times x to the power of minus 2 minus 1. Then I need to simplify that. If I simplify it, this 3 into 3, 1, I'll get 3 into 6, that's 2. 4 into 4, 1, 4 into 8, that's a 2. Right? This 2 here cancels with that 2. Then I'm going to end up having the following. This will be 2x to the power of 5. Then I'll have minus 2 here times 3. That will be minus 6x to the power of 7. Then this minus 1 times that 1, I'll get negative 1, which I can just not write and put x to the power of negative 3. So this will be the derivative of that trinomial. Alright? Then I'll do the last one, that's you for today. Right? Now for you, our a is a constant. And again, it's a trinomial. Therefore, the derivative of a squared is going to be a 0. Okay, so let me do that quickly. So u, we have the differential operator, we get a squared, x squared, so it's x cubed, right, plus a squared plus x cubed. This is equal to, okay, this is equal to the exponent of the variable times the constant, which is a squared. So you get 3a squared x to the power of 3 minus 1, which is 2. Then the derivative of the constant is 0. Then this one here becomes plus 3x squared. And then you are done.